Hello students, welcome to this video tutorial on solving algebra problems with Algebra Tiles Supernote. Part 1, using addition or subtraction. So for these problems, for these algebraic equation problems, we're going to provide two separate answers, an algebra tile diagram solution and an algebraic solution. So this is a pretty new concept, so we're going to go slow and we're going to have a lot of examples. All right, so under part 1, using addition or subtraction, let's have a look at example 1. We have a very simple algebraic equation here, x plus 2 equals 4. So you've done a lot of work drawing algebra tile expressions, so we're going to use that to take it one step further and solve for algebraic equations. Okay, so let's break this down in a couple steps. So step 1, what we do is we draw the question. So let's look at the individual components. So we have an x variable. Okay, we've had a lot of experience drawing a positive x variable. It's just a rectangle with a positive sign. Then plus 2. Plus 2 is simply 2 positive integer tiles. And then we have the equal sign. Don't forget the equal sign. And then on the right side of the equal sign, we have positive 4. So let's draw those tiles out. Positive 4. Okay, so we're just going to write a reminder here of what we did. Okay, so diagram 1 is draw the question. Okay, so write that down as part of your note. So step 1 or diagram 1 is we're going to draw the question. Okay, in diagram 2, what we're going to do is we're going to copy the question and then we're going to start to solve it. So I'll give you some strategies on how to do that. So I'm just going to copy my first diagram. Okay? So I want you to ask yourself a series of questions. First question is, which side is the variable on? So if we look at our diagram, we locate the variable is here. So it's on the left side of the equal sign. If we look at our question, we see that the variable is on the left side of the equal sign. So what we want to do is we want to focus on the left-hand side. The left-hand side is x plus 2. So what I want is I want x to be alone. Well, what's in the way of x being alone? Well, these two positive tiles. Well, working in this unit and our integer unit, we know how to get rid of two positive tiles. So what do? We add two negative tiles. Now, whatever we do on the left side, we also have to do on the right side so it's balanced. So if we added two negative tiles here, then we have to add two negative tiles here. Now I've drawn them in red just to show that this is part of this step. This is new for this step. So if we examine what we've drawn here, now we can see that we have two zero models on the left-hand side, which we will take away. Make sure you draw that arrow there. Okay? And we also have created two zero models on the right hand side, which doesn't always happen, but in this case it does. Okay, so we're going to circle them and we're going to take those away as well. Okay, so let's summarize here on the right hand side what we did. So I'm going to draw a bracket here. So what we did was we work to get x alone. By using zero models. Okay? Okay. So here's what I mean when I say getting x alone. If we take away these zero models and we take away these zero models, our third step is let's draw what remains. Well, on the left-hand side, what remains is x, and that's what we wanted. We wanted x alone. Remember, this is all gone. If these were actual tiles in front of you, you would take them away. Then we have the equal sign. Don't forget the equal sign. Remember, these are all algebraic equations. And what's left on the right-hand side? Well, we have two positive tiles. So if you were to translate this diagram here, the answer would be x equals 2 or positive 2. Okay, so as a note here, let's write in brackets, draw what remains. Okay. All right, so that's the algebra tile diagram solution for example 1. So what we like to do is we always like to pair the tile solution with the algebraic solution. Okay, so the algebraic solution doesn't require as much room, but it basically follows the same steps. So what we can do is we can actually correlate each step from the algebra tile solution, from the tile solution, yeah, to the algebraic solution. Okay, so step 1 is easy and it doesn't take much time. We simply copy the question. Okay, just like we did on the algebraic tile diagram solution side, we drew the question, and on this side, we're just going to copy the question. Step 2, we copy the question, but then we work on the question. Okay, so remember that question, those questions I asked you? What side is the x variable on? Well, it's on the left-hand side. So let's focus on the left-hand side only. We want x to stand alone. So what's in the way of x being alone? Well, we have positive 2. We want to get rid of positive 2. So to get rid of positive 2, we do the opposite. So instead of adding 2, we subtract 2 on both sides. Now this is very important that you write this part in here to show me what you're doing. We're subtracting 2 on both sides, and that's why I chose red. Okay? So here's what happens algebraically. A plus 2 minus 2, if you just work that out in your head, 2 minus 2 is 0. So in essence, it cancels each other out. And then 4 minus 2, right, equals 2. Now this is not going to cancel each other out. 4 minus 2 is simply 2. Okay, so in the third line, we'll drop down here so it kind of is lined up with our tile solution. We draw what remains. Well, what remains is this x, that x is untouched, and it's alone because this cancels each other out. Positive 2 subtract 2 is 0. It cancels each other out. This, don't forget, the equal sign. And then here on the right-hand side, we just worked it out. 4 minus 2 equals 2. Okay, so I'm going to go back and I'm going to draw these arrows here so that I can show that my solutions line up with each other. Every line should be the same on both sides of your solutions. Okay, now here's the other way that you can check. Now you have to make sure that this diagram here matches this algebraic equation over here. That's another way that you can check, right? This is x equals 2. On this side, we have x equals 2. Okay, so that's the first example. Hopefully it wasn't too difficult. All right, so let's go to example 2. Example 2 is x minus 3 equals 7. Now remember, this is part 1, using addition or subtraction. In this case, we use subtraction, right? We subtracted 2 on both sides. So let's see what we have to do for this question. All right, step 1, remember, draw the question. So let me give you a 10-second head start. I want you to draw this question right here using your algebra tiles. So we have a positive x, and then we have minus 3 or negative 3. And then we have the equal sign. Don't forget the equal sign. And then on the right side of the algebraic equation, we have 7 positive tiles. Okay, that's not too many. Okay, so that's step 1. Step 2, copy step 1. Okay, let's go through those series of questions. What side is the variable on? Well, the variable x is on the left-hand side. So let's focus on the left-hand side. We want x here to remain alone. So what's in the way of x being alone? Well, these 3 negative tiles. How do we get rid of 3 negative tiles? How do we negate 3 negative tiles? Well, we add 3 positive tiles. Now remember, I'm only focusing on the left-hand side. Right now, I'm totally ignoring the right-hand side. So if we added 3 positive tiles, we would get rid of the 3 negative tiles. Now we have to add 3 positive tiles exactly, not 4 positive tiles, not 2 positive tiles, because that wouldn't solve our problem of getting rid of the 3 minus tiles, 3 negative tiles. All right. So we know that that is going to create a zero model, and this is going to go away. That's good. Now, whatever we did to the left-hand side, we also have to do to the right-hand side. So we added 3 positive tiles to the left-hand side. So we're going to add 3 positive tiles to the right-hand side. Okay? Now, in this case, unlike the previous question, there are no zero models created on the right-hand side, and that's fine. Okay, I only wanted to create zero models on the left-hand side where the variable is. Okay, so do you remember what line 3 is? Line 3, we draw what remains. So let me give you a head start. See if you can come up with the answer. So on the left-hand side, we have x alone, right? Because this was taken away. That's what we wanted. We wanted x to stand alone. And then what remains on the right-hand side? Well, it looks like we've added some tiles. So if I count them up, it looks like there are 10 positive tiles. One, two, three, 4, 5, 6, 7, 8, 9, 10. All right, so that should be our answer. How would you say this? X equals positive 10, or x equals 10. Okay, so let's do it algebraically now. So step one is easy. You don't even have to think about your strategies yet because we just copy the question. Step 2, we copy the question again, and then we start to think about our strategies. Okay, so we ask ourselves those same questions. What side of the equation is x on? It's on the left-hand side. So we're only going to focus on the left-hand side. I want x to stand alone. What's in the way of x standing alone? Well, negative 3 is. Subtract 3. How do we get rid of subtract 3? Well, we do the opposite of subtract 3. And the opposite of subtract 3 is to add 3 on both sides. We have to do it on both sides, and you have to show this step here, or else I won't know what you're thinking. All right, so what happens here? Negative 3 plus 3 cancels each other out. Now, what I mean cancels each other out, it means the net result is 0. On the right-hand side, 7 plus 3 is 10. Okay, so let's go to step 3, where we write what remains. In other words, we write the answer. So what remains here? We have x. From here, negative 3 plus 3 cancels each other out. It's 0. We have the equal sign, and then we have our answer, 10. Okay? Then we check, does this algebraic solution match our tile diagram solution? Yes, it does. Okay? All right. So let's go on to the last example in this section. So I hope it's starting to make sense. So how about I give you a head start here? Okay, step 1 for the tile diagram solution is we draw the question. We have x plus 3 equals negative 4. Step 2, we copy the question. Okay? And then we start asking ourselves those questions. Number 1, which side is the x variable on? It's on the left-hand side. So let's focus only on the left-hand side. We're going to ignore the right-hand side. We want x to stand alone. So what's in the way of x standing alone? 3 positive tiles. How do we get rid of 3 positive tiles? Well, we combine them with 3 negative tiles to create 3 zero models. Now, what you do on the left side of the equation, you also have to do on the right side of the equation. So don't forget to draw your 3 negative tiles on the right-hand side as well. Now, once you draw the 3 negative tiles on the left-hand side, you'll have a zero model, and that's exactly what you want. You always want to create a zero model on the left-hand side. Now, are there any zero models created on the right-hand side? No, and that's okay. That doesn't always happen. Okay, so your solution line, we're left with x on the left-hand side, which is what we want because this is a zero model. It's been taken away. And then on the right-hand side, what are we left with? We're left with 7 negative tiles. 1, 2, 3, 4, 5, 6, 7. Okay? All right, so our answer should be x equals 7. Okay, let's go over to the algebraic solution. Step 1. Remember, step 1, you're not even thinking about strategies. You're just copying the question. Step 2, you copy the question, and then you work on it. Okay, so again, you go through those series of questions. What side is the x variable on? It's on the left-hand side. So we'll focus only on the left-hand side. I want x to remain alone. What's in the way of x being alone? Positive 3. How do we get rid of positive 3? Well, we do the opposite. If we're going to add 3, then the opposite is to subtract 3 from both sides. Okay? So let's see what happens here. Positive 3 subtract 3 is 0, so that cancels each other out. So make sure you draw a slash through it. And negative 4 subtract 3, so here's why it's very good that you keep up with your integer skills, right? Negative 4 subtract 3 is negative 7. Okay, so step 3, we draw what remains. What remains is x. This cancels each other out. This is an equal sign, and we already determined that our answer was negative 7. Okay? Now again, this diagram should equal this algebraic solution. That's one way of checking your answer. Okay, so this concludes part 1 using addition subtraction of this supernode. Thanks for watching. Bye.